right. Action potentials are going to be propagated all the way down a neuron. So there's two ways that this occurs. So if we have a neuron, and here's its axon, dendrites going on there. When the action potential is propagated down a neuron, it will depolarize with every voltage-gated channel that's on here. So there's voltage-gated channels. There's voltage-gated channels for sodium and potassium, all the way down the axon, starting at the hillock. So if this is the axon hillock here, then they start here. And they start there, and there's both of them there. So sodium, potassium, sodium, and it goes all the way down. So when the action potential goes down, is propagated down the axon, all of these gates are going to open. So they all open and close, and they don't all do it at the same time. They start here and then do it as it goes down to the terminals. So this one opens, then this one opens, then this one opens, then this one opens, and so on and so on and so on and so on, all the way down. And they don't stay open. It opens and then then this one opens and that one closes, and then this one opens and then that one closes, and so on. Until we get all the way down here, and then they're all closed again. When the action potential has to go through, or when every single voltage-gated channel has to open, that is called continuous conduction. So that means every single gate, every single voltage-gated channel opens and closes along the axon. So that seems not very fast. Okay. If we look at this neuron here, same thing. Here's my little thing going down here to my terminals. Okay, but this neuron, we're going to myelinate. So those are the Schwann cells that come over here and wrap themselves around the axon, leaving little gaps between these cells. Remember, those were nodes of Ranvier. So now when we get an action potential, so it starts here, goes here, open, close, open, close. Once we get to the myelination, to the Schwann cell, so this is myelin, that myelin insulates the axon that it's covering. So that means that the action potential can't get to, we can't get to those gates that are there, those voltage gates. The voltage doesn't even go there, okay? So the voltage then hops from here to here, to this node. And there'll be gates there, or channels with gates there. sodium and potassium, so those will open on that node. And then when it runs into the next myelin, it will jump again to the next one. Same thing will happen on that part of the axon that's exposed. Those gates will open and close, and then it will jump to this one, and then to this one, and then to here. This is called saltatory conduction. And it's provided by the myelin sheath here. And it speeds up conduction. And that's very important, especially with some certain neurons, like motor neurons. Motor neurons are big and they're long. Okay, and they're innervating, big muscles. So they got to get that stimulation there quickly. Okay. So an unmyelinated axon utilizes continuous conduction. A myelinated axon uses saltatory conduction.